going forward here. All right, our theme for the day and the theme for this section is part over the whole. When you want to figure out a percentage, you do part over the whole. If we wanted to figure out the percent of sophomores in this room, we would count how many sophomores we have, we would count how many total people we have, and we would divide them and multiply by 100. That is the theme. Good? All right. So when we're looking at the law of definite proportions, remember a compound is always in a set ratio. So because of that, we can look at the proportion by mass. Sometimes that's called gravimetric proportion or gravimetric analysis. And you can determine the mass of an element divided by the mass of the entire compound times 100. That's going to give you your percent mass of the elements. And then what we're going to do later this year is we're going to take those and we're going to back up. I'm going to give you masses and you're going to have to give me the formulas for the masses. That's not for another few months, but this comes back to you later on this year. Okay, so we are going to start off here. We have a sample. That sample is 78 grams. That is the compound. It contains 12.4 grams of hydrogen. They want to know the percent mass of hydrogen. So the part is the hydrogen. So this is my part, and this is my whole. So 12.4 divided by 78 times 100 equals. So I end up with 15, and I usually round these to the tenths place. So 15.9, and that's going to be percent hydrogen. Easy enough? Part over the whole. I would expect without letting you practice that you can put this in your calculator properly. So, all right, we have 1 gram of hydrogen here. We're reacting with 19 grams of fluorine. What is the percent mass of hydrogen? See if you can set that up. So this time I'm given 2 parts. How do I find the whole? If I knew that there were 20 sophomores in here and 10 freshmen, which there's not 30 people in here. If I knew this, how would I figure out how many total people I have? Add them. So how do I find the total amount for this compound? 2 parts. You told me how to find the whole. Here I've got 2 parts. How do I find the whole? Add them together, right. Which part am I going to put on top of my equation?
I mean 1.0.
Right, 1.0 grams of hydrogen because they're asking about the hydrogen. I'm going to divide that by the whole, which if I add these together is 20 grams. I'm going to multiply that by 100, and I should come up with my answer, which is what? Anybody calculate that out?
5%.
5%. Good. And like I said, I typically will do this to the tenths place. And you need to use your percent sign. And you need to write what element it is, which is hydrogen. And again, you can use the abbreviations. Be careful though. Make sure that the first letter is capitalized and the second letter is always a proper lowercase letter. Remember, this would not be accepted for chromium. This would be chromium. Okay? Make sense? We've talked about that. All right. Here we have element X and element Y. They're going to form XY. They want to know the percent mass of X and the percent mass of Y. See if you can calculate that. You should have a calculator. All right, what'd you get? Okay, so I'm going to take 3.5 grams of X. I'm going to divide that by what? No. This is a part. This is a part. What is the theme? Part over the whole. How do I find the whole? Add them together. So try that again. 3.5 over 14. Good. Times 100. That ends up being 25% X. Now, the next step, I could either set this up again and put 10.5 here, or since there's two parts, what could I do to find out the final part that would be a little faster? Subtract from 100%. Exactly. Good. Okay. So if you only have two parts or you only have one remaining part, if you know the amounts of the first, you can just subtract from 100 and that'll give you the last value. Does that make sense? It's kind of like a pie. You know, if you had a pie here and you knew that this part here was X, then this rest of this part is going to be Y. So if this is 25%, the last part has to be 75%. That makes sense? Okay. Again, I could set this up as 10.5 grams X divided by 14.0 grams XY times 100. And then that would give me the same amount. You hope, if you did your math right. Okay? Everybody cool with that? All right. We have two unknown compounds. Compound 1 is 15 grams hydrogen and 120 grams oxygen. Compound 2 then is here. That's 2 grams hydrogen and 32 grams oxygen. Are they the same compounds? Well, if they have the same percentages of each element in the compound, then it's the same substance. If they don't, then they're different compounds. So do your compound 1 and compound 2 and see if those values are the same. And that's how you'll determine it. Go. What's your theme? What's the theme of the day? Heart over the hole. How do you find the hole? Add them up. Okay, so compound 1, I had 15 grams of hydrogen divided by what? 135, right. I need to figure out my hole. Times 100. When I do that, I get 11.1% hydrogen. Over here, I'm going to have 2 divided by 32 times 100. And here I get 6.25% hydrogen. Now, do I need to go and calculate the oxygen here for each of these? Oh, it should be 34. I'm an idiot. Let's try that again. Was that what you were going to say in the back there, Presley? All right, let's try that again. 2 divided by 34. Okay, how about 5.9%? Everybody happier with that? I was just seeing if you guys were paying attention, if you understood it or not. Are you buying it? No. Yeah, probably shouldn't. All right, my previous question stands though. Do I need to figure out my percent oxygen? No, I can just go and compare my hydrogens. I can see that they're different, and then from that, I can determine that they are different compounds. Yay or nay? Okay. All right. Now, the next one, we are going to start using our periodic table. So when you look at your periodic table that you have before you, you will notice many different things on there. Let me grab one so that I format it exactly in the same way. Make sure I have everything in the right corner. It depends on which periodic table you use as to what they stick in different corners. And so I want to make sure that I'm showing you exactly the way yours looks. So if you find sodium on there, it's in the first column, 3 down. Okay. Sodium is Na. This is that symbol. Again, when we write that, we don't write this. Okay. Notice that that's a lowercase a here. Up in the corner, they have an 11. This is called your atomic number. Okay. We're going to be working with that guy a lot when we get into our next unit. Down below there on your periodics table, it says 22.990. This is your atomic mass, and this is what we're going to be working with primarily in this chapter. Over here are some numbers. These are charges. When they lose electrons, this becomes their charge. And then down in the bottom here is, you know how they have electron levels? These are how many electrons are in each level. So we don't need to worry at all right now with these things here. They will come in future chapters. Right now, we're primarily concerned with this guy. In this class, we typically, in an AP, we will round to the 10th place. So if I wanted to take this number and round it to the 10th place, what would this number become? 23.0. That takes me to the 10th place. Okay. All right. So this, when we do these, when we figure out percent composition of a compound, what we do is we list the elements that we have. we list how many of them we have. So name or symbol, I guess it would be more appropriate. So symbol, number that we have, times atomic mass, and then we equal that, okay? So for my sodium, I don't have a subscript here, so how many sodiums do I have? How many sodiums do I have? 1. If there's no subscript, it's assumed to be 1. How many chlorines do I have? 1. You guys are a talkative bunch today. All right, I'm going to go over here and I'm going to grab this atomic mass that I have rounded to the 10th place, and then I'm going to multiply those together. Okay, now I'm going to go and I'm going to find chlorine on my periodic table. And it says 35.453. So what does that round to at the 10th place? The 10th place would be, huh? Come on, speak up. You guys can do it. 35.5. Good. Okay. So 35.5. All right. I now have my 2 parts. In order to figure out the percentage, what do I need in addition to the parts? What is the theme for the day? What is our theme? Part over whole, right. So how do I figure out my whole? How have we been figuring it out all day long? Add them together. Okay, so I'm going to add these together. And that's my whole. So to figure out my sodium, I'm going to do 23.0 divided by 58.5 times 100. Oh, 23, 58.5. And that ends up being 39.3. Notice I'm going to bring it to the 10th place. I'm going to put a percent sign because that's what we've calculated when we multiplied it by 100. And then my final part of this is going to be the element that we're talking about. Then I'm going to repeat that for the chlorine. And I get 60.7% chlorine. Now, when you get done here, if you add these 2 values up, what should they add up to be? 100%. So it's always a good double check of your work to verify that these indeed add up to be 100%. Occasionally, because of our rounding, you will get some that are 99.9, and sometimes you'll get 100.1. But if you end up with like 101, you did something wrong. Okay? So it's always a good double check of your work. And you can usually do this kind of mental math in your head to figure out, if you're right or not. Cool? All right, let's try one more. Or do we have, no, we have 2 more to try. Okay, so let's set this guy up. I have my carbon. I have my hydrogen. And I have my oxygen. Okay, I'm going to look and I'm going to count how many carbons I have. I'm going to count how many hydrogens I have and how many oxygens. Everybody cool with those values and the symbols that I have up there so far? Anybody not aware of where I got them from? All right, now I'm going to look on my periodic table. So see if you can find and fill in the masses for these, and then double check with what I've got written up here to see if you're correct. All right, how'd you do on that so far? Everybody happy? All right, let's see if you can find your part over your whole now. So I'm just going to take this guy, and I typically will just do it as part of the problem instead of rewriting it. If I can rewrite it properly. There we go. Okay. Did you get those percentages? Is this making sense? I have one more that we're going to do, or at least talk about. Everybody happy with it so far? Okay. All right. Anybody need more time on this problem before I move? Okay. We need to talk about this guy. I had a formatting issue, so that should be a big percent, or percent in parentheses. My apologies. All right. So let's talk about how we work with these and figure out how many atoms we have. So I have 4 different atoms that I'm dealing with here. Okay. BA is not inside the parentheses. So it is not subjected to this 2. This 2 only applies to the stuff that's inside the parentheses. So this BA, I have 1 of those. This parentheses essentially is like in math, okay? If you had 2 times 4 plus 8, right, you would distribute that. So this would become an 8, and this would become a 16. Okay? Let's make this an A and a B so that we can keep those separated. Does that make sense? How we distribute that? It's the same way here. it's as if we said, oh, come on. We said that we had a BA and we had C2H3O2 and we had another C2H3O2. So now we're counting all those atoms up. Okay. So we distribute through here. We're going to multiply. So 2 times 2 is 4. 2 times 3 is 6. And 2 times 2 is 4. So that's how we do our inventory of these atoms. Make sense? Do you want me to go through another part over the whole, or are you comfortable with getting this stuff off? You want me to do another one? Okay. Anybody want me to do another one? You're comfortable getting it off the periodic table? Okay. All right. Because I really want to spend some time talking to you about your lab tomorrow. So I'm going to hand out the lab now, and then we are going to talk about that. So the lab has 2 sheets. One sheet you are going to keep and never give back to me, and the other sheet you will do your work on and give back to me. Is this yours, Maddie? Oh, I better ask before I just throw it in my cup. They dropped them next year. The person's, I'm not sure. All right. I haven't done attendance yet. There's attendance. Really need to do attendance. I should remember to do attendance. The sheet that I'm handing out to you now is the one that I want completed and returned to me for credit. This lab should be done using complete sentences. You understand what's going to happen if you don't use complete sentences with this. All right, so there is one part of this on yours that I deleted off of here already. It talks about a formal lab write-up, so you can get rid of that. We're not going to do formal lab write-ups anymore. So, yeah, it's right above where it says procedure there. There's a section here that talks about a formal lab write-up. You can get rid of that. We're not going to do one. All right, so parts of this lab that you are going to need. The first part is a Bunsen burner stand. This is located under the sinks. The next 3 things here are located in your general equipment drawer. The length of magnesium ribbon should be in the center of the room. And your beaker tongs are going to be in the general equipment drawer. Okay, So let's talk about how we're going to set this up. What you're going to do is you're going to set up your ring stand. On your ring stand, you're going to place your iron ring. This is what an iron ring looks like. It has a clamp on the side with a screw. You're going to place that over the ring stand, and you're going to clamp down by turning the screw until it doesn't move. You're then going to grab your clay triangle, and you're going to place that on the iron ring. So your clay triangle will go here. Okay. You have in a white box typically, but not always, you're going to have a metal crucible with a lid. These then are your beaker tongs. Remember, when we use these tongs, we have the points pointing down so that we can move our hands back and forth, right? And they open and close like a pair of scissors. So you can lift the lid of the crucible up. You can lift the crucible up and move it around. Okay. The crucible will then be placed on your clay triangle. Okay. So you end up placing the crucible on top of here. I'll try to draw that in a different color so it'll maybe show up. So that gets placed on the iron triangle. I am not an artist, you guys, so I apologize. Okay. And then the other thing that you're going to need that wasn't listed here is one of these insulated tiles, because when you take the crucible off to cool, you need to place it on that insulated tile so that it doesn't mess up my tables. It's kind of like a trivet on your table at home. You put hot stuff down on countertops or tables or something. You have a hot pad. Okay. So that's your basic equipment. Now let's talk about the lab. When we are talking about the radiation and whether it's cooled enough to measure, you're going to be looking for these waves of radiation. Have you ever seen like pavement on a hot day where it looks like it's wavy when you look out across it? Okay, that's what we're talking about with waves of radiation. If you can look across that crucible and see that that's not happening anymore, then it's good enough to put on my balance and get a weight. Okay, what happens is when you have those waves of radiation, it messes with the mass. It doesn't calibrate, the scale doesn't measure the mass correctly. So that's why, one of the reasons why you have to let it cool before you can put it on there. Okay. The other one is that I don't want plastic parts of my balances melting. These crucibles are going to get stupid hot. Okay. They glow. If you get them going right, they actually glow like an orangish red. Okay. It is stupid hot. It will instantaneously give you at least second-degree burns if you touch these things with your hands. Okay. I had somebody reach across one and touch it with the part of their forearm here. Instant burns. Okay. So be very careful when you're moving things around. Now, you are going to fire the empty crucible for about 3 minutes. This is going to remove water, oils, and other contaminants. From this point on, you do not touch that crucible with your hands, because if you do, you might reintroduce those things to the crucible and give incorrect weights. You are going to record the mass of the crucible to 1/100th of a gram. So make sure that it's not fluctuating in that second position. Remember, your balances give you to the thousandths of the gram. So this value here should be stable. This one might still be fluctuating a little bit just because of wind currents and that sort of thing. You're going to get about 6 centimeters of magnesium. You're going to coil it. So what we mean by that is you're going to do it something like that. You don't want it super tight because you want air to be able to get in between the different levels here. Does that make sense? So you're going to loosely coil it, put it on the bottom of the crucible, record the mass of the ribbon and the crucible, and then put that on the clay triangle. You're going to set the lid just a little off. So you'll have your crucible here. And instead of the lid being firmly, tightly on it, okay, we are going to have it just slightly off so that there's a little bit of room here for oxygen to get in there. You're going to place the Bunsen burner under the crucible, light it. You're going to brush the bottom of it. So by that we mean, let's pretend that this right here is my Bunsen burner, okay? I'm going to take it and I am going to brush the bottom by moving my Bunsen burner back and forth under that crucible. So I'm going to do this guy. That's brushing it. Once you've gently heated that for a few minutes, then you can put your Bunsen burner underneath here and go full bore. Okay? You're going to heat it until, and you can peek inside that lid. You're going to peek in until it turns kind of a grayish white. Stop heating and allow it to cool until you no longer see those waves of radiation. You're going to add about 10 mils of distilled water to the solid powder. You're going to heat it again with it slightly ajar for about 2 minutes. Allow it to cool and then measure the mass. I have a 2.5 minute video here that I expect you to watch before you come in tomorrow so you understand how to work this equipment. Okay? That's what I'm asking for by tomorrow is 2.5 minutes. You also have 3-4 that is due to me by Thursday. So make sure that you're keeping up with your homework. Okay. So 3-4 is going to be due.